Read this problem. A particle starts from position x is equal to 20 meters with an initial velocity 4 meters per second. Variation in its acceleration from t equal to 0 to t equal to 20 is shown in figure. Draw velocity time and position time diagrams for the duration. Find maximum velocity reached by the particle and the total distance traveled. We'll first focus on drawing Vt and xt diagram. Now watch this diagram, AT diagram. What you should understand from this diagram, listen. From t equal to 0 to t equal to 10, it is uniform acceleration motion because acceleration is constant and that is 3 meters per second square. From t equal to 10 to t equal to 20 seconds, it is variable acceleration motion. But one more thing you should understand here. Somewhere between t equal to 10 to t equal to 20 seconds, at a particular instant, acceleration becomes 0. Now during motion, when acceleration becomes 0, velocity reaches maximum value. So this instant is important where velocity is maximum, acceleration is 0. Up to this particular instant, acceleration is positive. And after this instant, when acceleration becomes 0, acceleration is negative. So it is retarded motion. So of course from this point onwards, from this instant onwards, velocity starts reducing. So here when acceleration reaches value 0, velocity has reached its maximum value. So this instant is also very important because from this instant onwards, it is a retarded motion starts, a decelerated motion starts. Okay. So first of all, let's find this important instant. This is the given diagram. Watch these two triangles. These two triangles are similar because both are right angle triangles and in fact all three angles are same for the two triangles. So base of this larger triangle, our focus is on these two triangles. Base of larger triangle, let it be A. So of course base of this smaller triangle is 10 minus A. How come? So watch here. From t equal to 10 to t equal to 20, this entire duration is of 10 seconds. So this length is 10 minus A, so remaining length is 10 minus A. Now use geometry of similar triangle. What is that? Base by height of bigger triangle is equal to base by height of smaller triangle. Now here we just want to know this length. That is, we are studying geometry of triangle. This height, don't consider negative sign because we are considering it as a length of a triangle. So base by height of bigger triangle is equal to base by height of smaller triangle, and we have found out A. A is equal to 6. So this length is 6. Because this length is nothing but corresponding duration, I have used that unit here, seconds. So 10 plus 6, that is this instant, is 16. So that means at t equal to 16, acceleration becomes 0. So at t equal to 16, velocity is maximum. And from t equal to 16 onwards, it is decelerated motion. So how important this instant you must have understood, and at the same time, how simple it is to calculate this instant, that also you must have understood. It's geometry of triangles. Now let's proceed. We want to draw Vt diagram first. So you should find velocity values at all these important instants. T equal to 0, t equal to 10, t equal to 16 and t equal to 20 seconds. What information we have? At t equal to 0, v is equal to 4 meters per second and x is equal to 20 meters. Now to find velocity, you are using this AT diagram. How AT diagram is related with velocity? Area under AT diagram is change in velocity. So use this formula now to find velocities at important instants. So first time interval, time at which velocity known, time at which velocity to be found out, in the sense t equal to 0 to t equal to 10 seconds. So consider this duration 0 to 10 seconds. Area under AT diagram, it is rectangular area, 10 into 3, that gives you final velocity minus initial velocity in this interval, that is velocity at t equal to 10 minus velocity at t equal to 0, and you have found out the answer, because t equal to 0 is 4. At t equal to 0, velocity is 4 meters per second. So put this value here and you will get the answer. Now next duration 10 to 16 seconds. It is triangular area, base 6, height 3 by 2, base into height by 2. And this gives you change in velocity in this interval, that is velocity at t equal to 16 minus velocity at t equal to 10 seconds. Now put value of velocity at t equal to 10 seconds, 34 meters per second, and you have found out velocity at t equal to 16 seconds, that is 43 meters per second. Now next duration, t equal to 16 to t equal to 20 seconds, this duration. It is triangular area, 4 into minus 2. Remember, here it is acceleration, it is negative. You don't forget to use that negative sign of acceleration. That gives you change in velocity. So velocity at t equal to 20 seconds minus velocity at t equal to 16 seconds, and velocity at t equal to 20 seconds is 39 meters per second. Now we are ready to draw VT diagram. So along x-axis time in seconds, along y-axis velocity in meters per second, and this point represents t0 and v0. Now let's plot all these points. So first of all, instants 10, 16 and 20 will mark here, taking care of proportion. It's 10. So next 10 means 20, and in between 10 and 20 will mark 16 closer to 20. Now velocity values which we have found out, first is 4 meters per second, that's given, then 34, 43 and 39. Highest value we should mark first, 43. Now with reference to 43, I will mark 4. Now it is slightly less than 1/10 of 43. 1/10 of 43 is 4.3, slightly less than that. So I marked here 4. Then 34. Okay, so it is 3/4. So this is how I have inserted all these values. Now plot the points. This is first point. At t equal to 0, velocity is 4 meters per second. That is given. Now at t equal to 10 seconds, velocity is 34 meters per second. So this is how we have marked that point. Then at t equal to 16 seconds, velocity is 43 meters per second. So at t equal to 16 seconds, here we have marked a point on VT diagram. And at t equal to 20, velocity is 39 meters per second. So this is how I have marked here. At t equal to 20, velocity is 39 meters per second. Now join these points, but shape of the curve, to identify that correct shape of the curve, refer AT diagram. Why? Because acceleration is slope of VT diagram. 0 to 10 seconds, acceleration is constant, means slope of VT diagram is constant. Check here, it is straight inclined line. Now 10 to 16, acceleration is reducing, so here slope should reduce. So draw reducing slope curve. Not only that, at t equal to 16, acceleration is 0. So slope should become 0 here, means that curve should become horizontal at t equal to 16. After that, acceleration increases on the negative side. Negative acceleration increases. That means here negative slope increases. And negative slope increases means downward slope increases. So again increasing slope curve, but draw in such a way that downward slope increases. So this is that shape of the curve. Here it is highest velocity reached. Also, this portion meets the straight line at t equal to 10 seconds. There must not be sharp corner here. Take care. When you get sharp corner in VT diagram, when there is vertical straight line in AT diagram. There is nowhere vertical straight line in AT diagram. Vertical straight line in AT diagram is sudden change in acceleration. So this is how we have completed VT diagram. Now let's proceed for XT diagram. Now AT diagram is given. Tell me how we can relate AT diagram with position. So it is moment of area under AT diagram. So what is that exact formula? moment of area under AT graph from T1 to T2, and this moment is about T2, plus initial velocity into duration. This gives you change in position. What information we have? At t equal to 0, v is 4 meters per second and x is 20 meters. So at t equal to 0, x is 20. So first duration, the time instant at which position is known and instant at which position to be found out. So 0 to 10 seconds. Moment of area. What is area? 10 into 3. That is area. It is rectangular area. Into 5. It is distance of centroid from t equal to 10 seconds, and it is half of its base, 5. That is why 5. Plus initial velocity. Initial velocity means in this interval initial velocity. What is initial velocity at t equal to 0? 4. So initial velocity into t2 minus t1, that is 10 minus 0. This gives you final position minus initial position. Initial position is 20. Put it here and you will get the answer. This is position at t equal to 10 seconds. Now next interval 10 to 16. In this interval, moment of area. What is that area? Base 6, height 3. So 6 into 3 by 2 into distance of centroid. Now this right angle triangle has base 6. So 1/3 of base, that is 2 meters, but 2 meters is distance from vertical edge of the triangle. But we want a distance of centroid from t equal to 16. It is moment of area about t equal to t2. So in this case t2 is 16. So we want distance of centroid, which is 2 meters from this vertical line, but from t equal to 16 its distance is 4 meters. So 4 meter distance. That is why it is 4 here. Plus initial velocity. Initial means in this interval initial. So at t equal to 10, what is velocity? 34. So that is what we have used here. Into t2 minus t1, that gives you x at t equal to 16 minus x at t equal to 10. Now put value of x at t equal to 10 here and you will get x at t equal to 16 seconds. Now next time interval 16 to 20 seconds. Moment of area. So area is 4, that is base. 16 to 20, that is 4. Height is minus 2. Here it is acceleration. Take care of negative sign. Into 4 by 3. How come 4 by 3? Base is 4 and centroid lies at a distance 4 by 3 from vertical edge. So this distance is 4 by 3. Plus initial velocity. Initial velocity means in this time interval t equal to 16. So t equal to 16, initial velocity is 43. So 43 into t2 minus t1, 20 minus 16. That gives you change in position in this interval. So x at t equal to 20 seconds minus x at t equal to 16 seconds. So this is how we have found out x at t equal to 20 seconds. It is 611.33 meters. Now we are ready to draw xt diagram. Along x-axis time in seconds, along y-axis x in meters. Insert the instants 10, 16 and 20, 10, 16 and 20. Now position values along vertical axis. Position, highest position first, that is 611. And with reference to that mark all other values. So 450. This 600, so 450. 210, nearly 1/3 of 600, 200, so somewhere here. And then 20, nearly 1/10 of 210. This is how take care of proportion. You need not draw to the scale diagram, but you will have to take care of proportion so that you will get correct shape. So at t equal to 0, x is 20. So I marked here first point on the curve. Then at t equal to 10, x is 210. Here I mark second point. Then at t equal to 16, x is 450. So I have marked here, and at t equal to 20, x is 611.3. Now these points are to be joined properly. Now it is xt diagram, and to draw xt diagram will take help of vt diagram, because velocity is slope of xt diagram. So here is vt diagram. Now check here, from 0 to 10 seconds velocity is increasing, so here slope should increase, and this is how you complete the curve. 0 to 10 second increasing slope curve. Now check here, 10 to 16 velocity is increasing. What is velocity at t equal to 10? 34. And what is velocity at t equal to 16? 43. So velocity is increasing. Don't get involved in the shape, just check magnitude of velocities. So velocity is increasing, so here slope should increase. So increasing slope curve, again I have continued. It is not straight line, slope is a slight curve here, and slope is increasing. So increasing slope curve. Now 16 to 20 velocity is decreasing. What is velocity at t equal to 16? 43. What is velocity at t equal to 20? 39. So velocity is reducing, so here slope should reduce. So this is again a curve. So increasing slope curve, then again increasing slope curve, and then decreasing slope curve. This curvature is very slight, but there is curvature. There are nowhere straight lines involved. So this is how we have completed xt diagram. This portion is parabola. Remember, horizontal line in acceleration time diagram. So inclined line in vt diagram, and parabola in xt diagram. And from 10 to 20 it is inclined line in AT diagram, so it is parabola in VT diagram. This is parabola, and it is cubic curve in XT diagram. You are asked maximum velocity reached. It is 43 meters per second and occurs at t equal to 16 seconds. Don't just write maximum velocity value. When it occurs, you should mention there. And what else? The total distance traveled. Total distance traveled is equal to displacement, and displacement is change in position. Remember, particle does not change its direction of motion. Throughout the motion, velocity is positive. When particle does not change its direction of motion, displacement is equal to distance traveled. When particle does not change its direction of motion, distance traveled is equal to magnitude of displacement. So we should find total displacement, that is from t equal to 0 to t equal to 20, and magnitude of that displacement, that is total distance traveled. So total displacement is equal to final position minus initial position. Don't forget, final position is at t equal to 20, initial position at t equal to 0. So 611.3 at t equal to 20, position is 611.3, and at t equal to 0, position is 20. So that is change in position. So it is 591.3 meters, that is total displacement. And since particle does not change its direction of motion, check, throughout the motion velocity is positive, means particle is moving in positive direction. So distance traveled is 591.3 meters. So this is how we have answered it properly. A particle starts at origin, so at t equal to 0, x 0, and moves along a straight line. Variation in its velocity from t equal to 0 to t equal to 30 seconds is shown in figure. Now in this problem, VT diagram is given. Draw AT diagram and displacement time diagram for the duration. Find total distance traveled. Also you are asked to find total distance traveled. So let's proceed. VT diagram is given and the information is at t equal to 0, v0 and x0. So at t equal to 0, velocity 0, it starts at origin. We are going to draw AT diagram now. How VT diagram is related with acceleration? So acceleration is slope of VT diagram. So we'll use that logic. Acceleration is slope of VT diagram. Now this is what you know, the slope of curve y is equal to fx is dy by dx. Similarly, the slope of curve v is equal to ft, nothing but vt curve. is dv by dt, and that is acceleration. Okay, so consider duration 0 to 10 seconds. V is equal to the curve, V is equal to ft. In this case, V is 0.2 t squared meters per second. So acceleration is 0.4 t meters per second square. Have you realized it is straight line? A is y equal to mx plus c. It is straight line where c is 0. Now acceleration at t equal to 0 is 0, and acceleration at t equal to 10 seconds is 4 meters per second square. Now consider duration 10 to 25 seconds. But in this duration, velocity remains constant. What does that mean? Acceleration is 0. Now consider duration t equal to 25 seconds to t equal to 30 seconds. Now acceleration is slope of Vt diagram. So now we are drawing slope. We are finding slope of this inclined line. Slope of a straight line, delta y by delta x. In this case, delta v by delta t. So what is change in velocity? Final velocity 0, initial velocity 20, and it is base is 30 minus 25, that is 5. So what is slope? Minus 4. Of course it is downward slope, so you should get negative answer. So acceleration is minus 4 meters per second square, and it is constant. Slope of Vt diagram, it's straight line. Vt diagram is a straight line, means slope is constant. And now let's draw AT diagram. Along x-axis, it's time in seconds. Along y-axis, it is acceleration. And check here. First, we'll insert these instants 10, 25 and 30. Now we'll insert acceleration values. 4. At t equal to 10, acceleration is 4. Then minus 4. And now let's draw the diagram. T equal to 0 to t equal to 10 seconds, it is straight line. At t equal to 0, acceleration is 0. At t equal to 10, acceleration is 4, and AT diagram is straight line. Now 10 seconds to 25 seconds, acceleration is 0. That is what we have shown here. And from 25 to 30, acceleration is minus 4. So 25 to 30, acceleration is minus 4. So this is how we have completed AT diagram. It's very simple. We'll draw XT diagram. Moment of area under AT diagram plus initial velocity into duration, that gives you change in position. We'll use this logic. Once you know AT diagram, you can use this information. Consider duration t equal to 0 to t equal to 10 seconds. 0 to 10 seconds. Moment of area, base is 10, height is 4. 10 into 4 by 2, that is this triangular area, into distance of its centroid from t equal to 10. It is moment about t equal to t2. In this case 0 to 10, so t2 is 10. So from t2, that is from t equal to 10 seconds, distance is 1/3 of 10. So that is why 10 by 3. Plus initial velocity is 0. 0 to 10 in this diagram, initial velocity is 0. In this instant, initial velocity is 0. That is equal to change in position. So x at t equal to 10 minus x at t equal to 0. And you have found out the answer. X at t equal to 10 is 66.67. Now next time duration, 10 seconds to 25 seconds. Moment of area under AT diagram is 0, because area under AT diagram is 0. So 0 plus initial velocity. Now 10 to 25, initial velocity is 20 meters per second. Into the duration, t2 minus t1, 25 minus 10, 25 minus 10. This gives you change in position in this duration. So put x at t equal to 10 here, and you will get x at t equal to 25. Now next time duration 25 to 30. In this duration, moment of area under AT diagram. So base is 5, height is 4. but don't forget to consider negative sign for its acceleration here. Into 2.5, how come 2.5? Centroid. It is rectangle, base is 5, so centroid is at distance 2.5 from both the ends. We are taking moment about t equal to 30 plus initial velocity. Now in this interval, initial velocity is again 20 into duration, it is 30 minus 25, and we got the answer. It is x at t equal to 30 equal to 416.67. X at t equal to 30 seconds is equal to 416.67 meters. So we know position values at all these important instants 0, 10, 25 and 30. At t equal to 0, x0 is already given. So now we are ready to draw position time diagram. Okay, along x-axis time in seconds and along y-axis, now wait here. We are not asked to draw position time diagram, we are asked to draw displacement time diagram. But remember, this is very important. Displacement is change in position, final position minus initial position. So when you want to find displacement at t equal to 10 seconds, final position minus initial position means 66.67 minus 0. So again you get the same answer. If you want to know displacement at t equal to 25, so it is final position minus initial position. So again 366.67 meters. So remember, when initial position is 0, then at any given instant displacement and position are same. So actually here position time diagram and displacement time diagram is the same diagram. Now insert instants 0, 10, 25 and 30, and now highest value first 416.67, and with reference to that we will mark all other values. 366.67, this is 66.67, and plot those points. At t equal to 0, displacement is 0 or x is 0. At t equal to 10, x is 66.67. At t equal to 25, x is 366.67. And at t equal to 30, x is 416.67. And don't get confused at all. If initial position is at origin, then at any given instant displacement and position are same. So position time diagram is nothing but displacement time diagram. Okay. Now we are going to join these points. Velocity is slope of position time diagram or displacement time diagram. Now let's identify shape of ST diagram 0 to 10. Now here velocity is 0, means slope of ST diagram is 0. So here ST diagram should start with a horizontal line, and then velocity increases. Don't get involved in shape, just check velocity values. Here velocity is 0, here velocity is 20, means 0 to 10 velocity increases. So slope should increase. So increasing slope shape. 10 to 30 velocity is constant, means slope of ST diagram is constant. Constant slope means it is a straight line. And 25 to 30 velocity reduces, so slope should reduce. Not only that, here velocity at t equal to 30 velocity becomes 0, so curve should become horizontal here. So this is cubic curve. Of course, watch here, acceleration time diagram is inclined line, VT diagram is parabola, XT diagram is cubic curve. Now acceleration 0, so VT diagram is horizontal line, XT diagram is inclined straight line. And AT diagram is horizontal line, so VT diagram is inclined line and ST diagram is parabola. So label these curves. Read this problem. A particle starts from origin with no initial velocity. Variation in its position from t equal to 0 to t equal to 20 seconds is shown in the figure. Draw VT and AT diagrams for the duration. In this case, ST diagram is given. 0 to 150 seconds, it is a parabola. Watch here, S is equal to t squared by 150. Y is equal to kx squared, that is a parabola. Okay, standard parabola it is. And 150 to 300, it is straight line. So let's start solving. First let's draw Vt diagram. At t equal to 0, V0 that is given. Now let's continue with Vt diagram. Tell me how velocity is related with St diagram. So velocity is slope of St diagram. So slope of curve S is equal to Ft is ds by dt, and ds by dt is nothing but velocity. So consider duration 0 to 150 seconds. St diagram is S is equal to t squared by 150. Differentiate it, so you got velocity as 2t divided by 150. It is in the form of a straight line, y equal to mx, and slope is 2 by 150. So Vt diagram is a straight inclined line with this slope 2 by 150. So this is Vt diagram, and as you know, when you want to draw Vt diagram, you should find velocity values at important instance. So at t equal to 0, velocity is 0. At t equal to 150, velocity is 2 meters per second. From this equation, you will get these two values. You cannot find velocity at t equal to 300 using this equation, because this equation is valid for this interval only, 0 to 150. Okay, now 150 to 300, consider the duration. In this duration, St diagram is a straight line, and how to find slope of a straight line? Delta y by delta x. In this case, delta s by delta t. So 150 to 300, change in displacement is 450 minus 150, and change in timing is 300 minus 150, and you got velocity 2 meters per second, and that is a constant. The reason is slope of St diagram is velocity, and slope of St diagram is constant, so velocity is constant. So 150 to 300, it is uniform velocity motion. So let's draw Vt diagram. Along x axis, time, important instance 150 and 300, and what is maximum velocity reached? 2. Check here, 0 to 150 it is inclined line, and 150 to 300 it is horizontal line. Now let's draw At diagram. Simple. Acceleration is slope of Vt diagram. So consider duration 0 to 150. In this duration, slope, it is straight line, so delta y by delta x, so 2 by 150, and it is 1 by 75 meters per second square. Now consider duration 150 to 300 seconds. In this duration, check, velocity does not change, so acceleration is 0. So this is At diagram, very simple. 150 to 300, acceleration 0, and 0 to 150, acceleration is constant, 1 by 75 meters per second squared. So it's very simple to draw At diagram now. So remember those 5 points to remember I have given you initially, and knowing those points, you will able to draw At, Vt, Xt diagrams easily. Of course, little practice is required. Read all those solved problems I have given you, and you will understand it better. Thank you.